Welcome back, students. After the discussion over the equations to calculate uh, the deflections of prestress concrete beams, so today in this lecture we'll solve a small problem for the calculation of deflections. Okay. So I'll read out the statement of the problem first. A concrete beam having a rectangular section 150 mm by 300 mm is prestressed by a parabolic cable at eccentricity of 75 mm at midspan towards bottom, okay, and at eccentricity of 25 mm towards top at support. So they are given the eccentricity at midspan and eccentricity at support, okay. The prestressing force is 350 kN. The beam supports a point load of 20 kN at midspan in addition to self-weight for a span of 8 meter. Find short-term deflection, and we have to find out the short-term deflection at midspan and long-term deflection if loss ratio is 0.8 and creep coefficient is 1.6. Okay. So these are the given data we have. So if you look out the diagram here, so they are given the beam of span 8 meter, in that eccentricities are varying. So at support they are given the eccentricity 25 that is upward, and at midspan they are given the eccentricity as 75 which is downward, and the load is 20 kN at midspan, that is concentrated point load at midspan, and along with there is a self-weight, and the cross section is 150 by 300. Okay, so you can see E1, E2, E1 is 25, E2 is 75, P is 350, EC if it is not given you can assume 30 kN per mm square. Loss ratio, which is very important, that is PF by PM, is final force and initial force, there is a loss is 0.8 and the creep coefficient is 1.6. okay. Then after that, okay, we have to find out the deflections as we discussed in last class. Okay, so there is again here we have to find out short-term deflection due to dead load, live load and prestress. So again, due to dead load, the deflection equation is 5WL raised to 4 upon 384 EI. So W is nothing but the self-weight, so you can easily find out, and I is BDQ by 12. So we can find out the short-term deflection due to dead load, and we got 4.49. We got 4.49. Okay, and the arrow showing downward means it is positive, means it is the deflection is downward. Because of dead load, we have got the deflection as downward, and we have got the deflection due to live load. So for live load, it is a concentrated load at midspan. So equation is, you have to go back and you have to check the equations. Okay, so that is WL cube upon 48 EI. So W is given 20. Okay, so according to that we got the deflection as 16.63 mm, which is again downward. So we have got the deflection due to dead load and deflection due to live load. Next we have got deflection due to prestress. Again here it is very important. So I told you in last class there will be two Bending diagram, that is because of P into E1 which is positive and P into E1 plus E2 that is negative. Okay, so for that we have got the values P into E1 and P into E1 plus E2, and we have to use these values for calculation of deflection due to prestress. Okay, then I told you how to calculate the deflection due to prestress again. So we have to use the formula that is based on Mohr's movement theorem, that is AX bar upon EI. So if you take AX bar, now I'll explain. A is nothing but the area of the bending diagram. So A is 8.75 which is mentioned here. Okay, sorry. So A is nothing but 8.75 into 10 raised to 6. Okay, so 8.75 into area is half of the bending diagram, that is length is 8000, so you have to take divided by 2 because half of the bending diagram, into X bar is again half of that because it is a rectangular section, divided by EI, minus, because P into E1 is plus, minus 35 into 10 raised to 6, 2/3 of 35 into 10 raised to 6 we can look at here because it's a parabola. 2/3 of 35 into 10 raised to 6 into half of the diagram is 4000 into the CG distance is 5/8 of 4000. Okay, so yesterday we have discussed about this. If you have any doubt you have to go back and you have to check. Okay, I have given the supporting documents also, you have to open that and you can take the print of that and you can solve the problem. So if you check, we have got the answer as minus 12.71, and arrow is upward, means the deflection because of prestress is upward, and minus an arrow indicating it is a upward deflection. Negative indicates upward, positive indicates downward, so arrow is also upward. Then we have got short term deflection is due to dead load, live load plus pre-stress. So 4.49 plus 16.63 minus 12.75. So ultimately we got the short term deflection is 8.41. Then again we have long term deflection. So this part I have not discussed. There is a small formula here. So long term deflection due to dead load, pre-stress, live load and creep. Okay, DL, LL, PS plus creep. So they are given the equation is delta IL minus delta IP into loss ratio bracket complete 1 plus 5. So delta IL is nothing but deflection due to load, that is DL and LL. So we have got 4.49 plus 16.3, and delta IP, P stand for pre-stress, so deflection due to pre-stress, we have got 12.78 minus 12.78, and loss ratio is given as 0.8 and the creep coefficient is given as 1.6. And when you come back and when substitute here, so you will get the long term deflection is 28.47. okay, so because 4.49 plus 16.63, this is the deflection due to load, and minus 12.74 is due to pre-stress. Loss ratio, that is PF by PI, is 0.8 and 1 plus 5 is 1.6. okay, so we got the deflection as 28.47, and the permissible deflection is given as span by 250. This is as per code, so the permissible deflection is 32 mm. okay, so this is a small problem where you have to find out the short term deflection and long term deflection. okay, now we will take up one more small problem. So all the data remains same in this problem as the previous problem. okay, only thing the load is changed here. So you can see here there is a 3 concentrated loads we have, 10 kilonewton, 10 kilonewton, 10 kilonewton at a distance of 2 meter. Eccentricity remains same. Only the change is phi, that is creep coefficient they are given as 1.8. So again we have to find out, we already have due to dead load, that is 4.49. okay, then deflection due to live load. So we have to calculate for loads, central load and due to load. So central load we have got again WLQ over 148 here as we have got in previous, so we got 8.3 mm. okay, then we got due to load at 2 meter. So this due to load, once you have to find out for center load and once you have to find out load at 2 meter from the support. okay, so for that again we have the equation this, and from that we got the deflection as 11.4 mm. okay, then we got deflection due to pre-stress. okay, I told you if there is a 2 eccentricity with point load, so we got PL square upon 48 E1 minus 5E2. so according to that we got 12.7 mm. so negative means upward. okay, then we got deflection due to pre-stress plus dead load. So pre-stress plus dead load is, they are asked to calculate the deflection due to pre-stress plus dead load. So pre-stress is minus 12.7 and the dead load is downward, that is 4.49. So ultimately we got deflection due to pre-stress plus dead load, that is negative 8.21, means it is upward. okay, the next long term deflection again. So in long term deflection it is again delta IL plus delta IP. So same here, so delta is due to load, so 4.49 it is because of dead load, and 8.3 plus 11.4, these are the because of the point loads. We got the delta IL 4.49 plus 8.3 plus 11.4, that is because of delta IL. And next we got because of pre-stress 12.78, the loss ratio is 0.8 they are given, and 1 plus 5, that there is a change here. In the previous problem it was 1.6, here they are given as 1.8. so ultimately we got the deflection is 39.28 mm. The long term deflection is 39.28 mm, that is downward. okay, so again this is a small problem we have, so we have to look out for both the problems, and again I am going to upload possibly on YouTube, and you have to go through that. okay, and I am going to release the supporting document, that is this document I am going to release. okay, but one thing, the YouTube viewers are not more, they are very less. I think all students are not going through the YouTube, so you have to go through. okay, see, this is like a real class after the starting of the college. We are not going to cover this part in the classroom, so you have to go through this. You have to solve the problems. If you got any doubt, you have to contact me, maybe here or maybe after in the college. But this is what we are not going to cover in the class, because we don't know where the semester will get extended or not. But you have to take care, you have to go through, and you have to solve these problems. In these problems, if you get any doubt, you have to contact me. Okay, so goodbye, best of luck.